is over exponent rules. You have seen these before, you've used these before, but you probably didn't really think about it that much. So you are going to know some of this. So the first one we're going to start with is the product rule. What does product mean? Anybody know? Product is when you multiply. So here's what the rule says, and then we're going to do an example. If I have x to the a power, some number, some exponent, and I multiply that by x to the b power, does anybody know what I do with the exponents? You do not multiply them. You add them. So a plus b. So when you're multiplying variables, you add the exponents. So for example, x to the 5th times x to the 3rd is x to the what? 8th, because you add 5 and 3. The power rule. This is when we have like x to the a, and that whole thing is raised to the b power. So we have exponents on exponents. What do you do with those exponents? Those numbers? Multiply them. So a times b. So for example, if I have x to the 5th and I raise that to the 3rd power, what do I get? X to the 15th. Next is the quotient rule. Quotient is when you divide, and a lot of times you see that as a fraction. If I have x to the a over x to the b. Any guesses on what I would do with those exponents? Subtract them. X to the a minus b. So if I have x to the 5th divided by x cubed, that's going to be x to the 2nd, x squared. Now the next two are new probably to you, and I will show you an example for why these rules are true, because they're going to seem kind of confusing. So the first one, the negative exponent rule. If I have x to the negative a power, that is the same thing. We don't want to leave negative exponents. That's the same thing as 1 over x to the a. So if you take this and move it to the bottom of the fraction, that exponent becomes positive. So for example, if I have 3x to the negative 5th, the only thing that has the negative 5 exponent is the x. That negative 5 exponent does not go with the 3. So this is equal to 3 over x to the 5th. Because that 3 did not have the exponent, it did not move. But the x, I moved it to the bottom, and that 5 became positive. And then the next one, x to the 0 power. What do you think this might be?
X.
It is not x. It is 1. So if I have 3x to the 5th, and all of that is raised to the 0 power, that whole thing is equal to 1. Anything to the 0 power is 1. And I'm going to show you kind of why these rules are true with an example. Yes?
For the x negative a, why don't you take the negative a?
Though to get it to turn it into a positive number, you put it on the bottom of the fraction. So like here, this negative 5 became a positive 5 by putting it in the bottom. So here's why that is true, or here's an example to show you. I'm going to find 3 to the 3rd, 3 to the 2nd, 3 to the 1st, 0. Notice I'm subtracting 1 from my exponents. So someone tell me, what is 3 to the 3rd power? Not 9. It's 3 times 3 times 3. 27. What is 3 to the 2nd power? 9. What is 3 to the 1st power? 3. Do you notice a pattern? We're dividing by 3. So what if I take 3 and I divide that by 3? You get 1. 3 to the 0 power is 1. This would work with no matter what number I was doing. Okay. So here I am at 1. Let's keep that pattern going. If I divide by 3, I get 1 over 3. Do you agree that 3 is the same thing as 3 to the 1st power?
Yeah, that makes sense.
Yep. So this one, so this negative 1, this is the same thing as 1 over 3 to the 1st. So this next one, if I divide this by 3, I get 1 over 9, which is the same thing as 1 over 3 squared. So when you have a negative exponent, it's the same thing as moving it to the bottom of the fraction, and that exponent becomes positive. So we're going to do some examples with these rules. So the first one, I am multiplying. I have 5x squared times negative 7x to the 6. When you multiply, if there are any numbers in the front, you still multiply those like normal. So we still do 5 times negative 7, which is what? Negative 35. And then we have the x's. X squared times x to the 6th. When you multiply variables, what do you do with the exponents? You add them. So we would have x to the 8th. So my answer is negative 35 x to the 8th. And it's super easy to check your answer. You can type in 5x squared times negative 7x to the 6th and get some random number. And then type in your answer. Negative 35x to the 8th. Do my two random numbers match? Yes. So that means I did it correct. Any questions? Number 2, this is still multiplying. When you have like a number or something in front of the parentheses, that means to multiply. So we have the 3 and the 4. What's 3 times 4? 12. and we have x times x to the 5th, which is x to the not 5th. This has a 1. It's x to the 6th. You add the exponents. So 1 plus 5 is 6. So 12 x to the 6th. Any questions? Now number 3, we have something raised to an exponent. This is the power rule. And what we do is we take everything inside and raise it to the second power. So we're going to raise them to the second power individually. What is 6 squared? 36. What is x to the 4th squared? X to the 8th. Because when you have, this is the power rule up here, you multiply those exponents. So my answer is 36 x to the 8th. Number 4, we're cubing, so we have 5 to the 3rd, x cubed to the 3rd, and y to the 3rd. So each piece is being raised to the 3rd power. What is 5 cubed? 125. X cubed is x to the 9th. Remember, when you have exponent to exponent, you multiply those. So x to the 9th, and then it's just y cubed. So 125 x to the 9th y cubed. Any questions? Now, these next one we're going to do is technically the quotient rule, but I like to look at it a little bit different than thinking about just subtracting the exponents, because sometimes that can lead into negatives, and then you got to do more. So when we have a fraction, we're going to look at the whole numbers in front. What is 18 over 2? 9. Okay. And then I have x cubed is x. And then on the bottom, I have an x. I don't expect you to expand it out every time, but we are going to do that a couple of times so you can see the pattern. And when we're dividing, we technically think that we cancel out. So I want to cancel one x on top and one x on bottom. Can I do that anymore? No. So I'm done. So my answer is 9x squared, because I had 2 of those x's left on the top. So when we think about canceling out, if I started with x cubed on top, x on bottom, I was able to cancel out one of the x's. One set. Okay. So let's do number 6 this way. 20 over 6. When you divide 20 by 6, do you get 20 divided by 6? Do you get a whole number?
No, you get 3.
Nope. So convert that to a fraction. It's what? 10 over 3. Good. All right. And then we have x to the 9th. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And x to the 3rd. 1, 2, 3. So then I can cancel out 3 times. And how many x's are left? 6. So my answer is 10 x to the 6th over 3. If you like writing it out, if that helps you, by all means, do that. But I don't expect you to do that. You don't have to. All right. So number 7, we have 8 over 16. What is that?
2. 4 over 8.
Okay, 4 over 8, which simplifies down further.
2 over 4.
Which simplifies further.
1 over 2.
1/2. So 1 over 2. And then the x's, I have 3 on top, 5 on bottom. When I cancel out, what am I left with? 2 on the bottom. Look, I have x, x, x. 1, 2, 3, 4, 5. They were left on the bottom. So it's 1 over 2x squared. Number 8. 25 over 35. 5 over 7. You can type this, if you don't know how, in the calculator. You don't know how to do it in your head. If you type in the fraction 25 over 35 and hit enter, it will simplify it for you.
You subtract those little exponents, right?
I mean, that's the quotient rule, but I'm not really thinking about it as subtracting.
I put 1, is that wrong?
Yeah, it is wrong. So if we have x to the 5th in the top and x to the 5th in the bottom, cancel, 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 cancel. All of the x's cancel, and yes, it's just 5 over 7.
That's what I had at first, but I'll put a 1.
Now 9 and 10, we throw in some y's, but the process is no different. We just have an extra piece to do. All right, 3 over 7. Does that simplify? No, it doesn't. So it just stays. Okay. Then look at your x's. If we cancel out some x's, what's left over? 4 in the bottom. So we have x to the 4th in the bottom, the denominator. And then we have some y's. So same thing. If we cancel out, what are we left with?
6y.
So y to the 6th in the bottom, in the denominator. So it's 3 over 7x to the 4th, y to the 6th. Are there any questions? Okay. Number 10. Six over 26 is what? 3 over 13. And then if we cancel out x's, what's left?
2x. Or 1x.
One of them, and is that in the numerator or denominator? The denominator, which is the bottom. What is y to the 0? It's 1. That whole thing is 1. So this is really like 13x times 1. Do you need the 1?
No.
No. 13x times 1 is just 13x. So that's not needed. So it's 3 over 13x.
That's good. I prefer y out.
And we're going to do 3 more. We're not going to do number 14. So these have multiple things going on at once. They're like the hardest ones you'll see of these. Okay, so we first need to do these power rules. So in the first one, I've got 3 squared and x to the 4th squared. What is 3 squared? 9. And what is x to the 4th squared? X to the 8th. Good. I'm holding. Have you lost your packet already?
I said maybe I'll pass this thing.
But have you? Do you have the packet, or are you doing it? Oh, you said let me write the equation out. I thought you were writing the question.
No, we just got them today.
Yes.
I wasn't here.
Oh, you just okay. I'm glad you didn't lose it. Don't lose this one.
I won't.
All right. Then we have 2 to the 5th and x to the 5th. What is 2 to the 5th?
Oh.
Close. You went too many times.
16, 32.
It is 32.
Let's do that.
And then x to the 5th. And so then we are multiplying those together. So go ahead and do 9x to the 8th times 32. See if you can do that on your own. So 9 times 32 is 288. And then x, when you multiply variables, add the exponents. So x to the 13th. Good. Let's do number 12 together. We have x to the 4th cubed and y cubed. What do I do with the exponents? Nope. Multiply them. Exponent by exponent, you multiply. X to the 12th, that just y cubed. And then I have 4 squared, x squared, y squared, squared. So I took each individual piece and put a squared with it. Kind of think about it as you're distributing the squared a little bit. What is 4 squared?
16.
What is x squared?
2.
X squared. What is y squared squared?
8. 4.
Y to the 4th. The exponent's 4.
Did you say 2 squared 2? You said that so where I swear it was an 8.
Y squared squared?
Yeah. Because it makes it sound like you're trying to square what you already squared, so then you just move it up to 8. So it'd be 2 times 2 times 2.
But it's just 2 and 2.
We're going to get these right.
So we have x to the 12th, y to the 3rd, 16, x squared, y to the 4th. Is there any of these that you don't know where I got them? Close. So now we're multiplying, because my problem is multiplying. Do you have anything to multiply to 16 by? No. So we just have 16. X's. I have x to the 12th and x squared. When you multiply variables, what do you do with the exponents? You add them. So we have x to the 14th, y to the 7th, because 3 and 4 is 7. And we're going to do one more. So the first part of this one is not the power rule. We have a fraction. What is 24 over 6? 4. And then I have x to the... If I started with 7 in the numerator and 1 in the denominator. So if I cancel it out, I'm left with x to the 6th. And I didn't have anything left in the bottom. What is 3 squared? 9. What is x to the 6th squared?
36.
Nope.
X to the 6th. 12.
X to the 12th.
Let's go.
You multiply. When you have x to the 6th raised to the 2nd power, you multiply those exponents.
You gotta quit saying weird stuff, man. You just gotta tell us. You gotta tell us that. You can't just say squared is squared.
I said x to the 6th squared. But it's when you have the exponents, you're not doing 6 times 6. You're doing 6 times 2. Because the quotient or the power rule, when you have x to the 6th raised to a power, you multiply the exponents. That's the power rule. Yep. All right, so now we're multiplying. 4 times 9 is?
36 to the 8.
Why did I put 3x? 36. X to the 18th. Good.